So today, my friend Deborah Arief and me, Fiona Goputri from Food Technology Swiss German University Indonesia, will talk about separation in product characterization. So, hope you enjoy it!
First, let's start with why we do separation. What is the aim of separation? Separation can increase the added value of a product by removing some specific components. For example, we have here is coffee. Coffee contains caffeine, and caffeine could be separated from the coffee through several processes. So, we have decaffeinated coffee. This coffee is suitable for people with caffeine-sensitive issues, and it has reached until approximately 10% of the world market of coffee. Also, separation could purify samples. For example, we have here a mixture with different types of compounds. We can purify them into their own categories and separate them. There are many types of separation, but what we are going to talk about today is the liquid-liquid separation, specifically in the liquid-liquid extraction. Liquid-liquid extraction is also called solvent extraction. Solvent extraction is described by Oxford dictionaries as partial removal of a substance from a solution or mixture by dissolving it in another immiscible solvent, in which it is more soluble, or we can call it as higher solubility. The basic principle of this process is we have two liquids. First, our sample, usually aqueous, and the other one is solvent. Solvent could be polar or nonpolar. Our solvent is supposed to be immiscible or not reactive with our base of aqueous, but it will still pull the solutes that we want into it. To say, our solutes will have higher solubility in the solvent compared to the base. First, we will mix our solvent with our aqueous solution or our sample. Even though naturally they are not mixable, through physical forces they could be dispersed into smaller particles and get into contact. The solutes will be in contact with the solvent, and the solutes will have higher or stronger bonding with the solvent compared to the base. So, the solutes will be transferred to the solvent. Next, we will separate our solvent from the solution through the density difference. The solvent will be above, and the solution will be under. We can remove them and separate them into two compartments. If needed, we can remove unwanted solutes in our solvent. That is called scrubbing. And then, we will harvest our solutes from our solvent. That's called stripping. Our carrier solvent will be free by now, and it could be reused again for the next cycle. This is the diagram of our process. Before entering the system, our solute is on the feed solution. But afterwards, it will stick with the solvent, and our feed solution becomes raffinated. This solvent extraction could be done serially. For example, first we use nonpolar solvent, and then less polar until the most polar solvents. Nonpolar solvents will pull nonpolar solutes, and also happens with the polar. The solubility will be nonpolar solvents toward nonpolar solutes, and polar solvents with polar solutes. So it depends on what we are going to harvest that we decide what solvent will we use.
Solvent extraction method is simple method with no complex equipment required. It has also controlled recovery and large selectivity and flexibility. But it may leave a trace of toxic solvent in product and waste, since the solvent is not a food-grade solvent. It has a slower and more expensive than solid phase extraction, and also it has a chance to lose of some compounds in the product. There is one product that using solvent extraction method in food industry, which is decaffeinated coffee. And the process is called decaffeination. Decaffeination's purpose is to remove nearly all the caffeine from the beans. It is carried out while the beans are still green, before they are roasted. Solvents that are usually used in the extraction process are ethyl acetate, methylene chloride, dichloromethane or DCM, or supercritical CO2. In general practice, the liquid solvent is circulated through a bed of moist cooked green coffee beans. removing some of the caffeine. The solvent is then recaptured in an evaporator and the beans are washed with water. Residues of the solvent are removed from the coffee to trace levels by steaming the beans. Solvent will be added to the vessel, circulated, and emptied several times until the coffee has been decaffeinated to the desired level. So that's all from us. Thank you for watching!